Hello everyone. In this lesson we will be learning about hazop study with practical example. With practical industrial example we will explain what hazop is and how hazop has been done, how the hazop report is being prepared. So let's dive into it. So what is hazop? Hazop is basically a qualitative hazard identification technique. If you go by the full form, it is hazard and operability study. This is very popular in the process industry. This follows a systematic approach to identify the hazard associated with the process and also uncovers the operability issues like approach not available or approach not available for a valve or it is at a particular height. So all these operability issues are also discussed in hazop. Now when hazop can be performed, hazop can be performed at the very initial phase of the design when just PNID uh, basic PNID is available. With the basic PNID the hazop can be started, and based on the hazop output the PNID can be modified before it is issued for construction. The next is modification. Whenever in the plant any modification has been done, any small or large modification, that time hazop again needs to be conducted, because the initial hazop uh, the modification has not been considered. So with the modification we can introduce new hazard or operability issues. That's why whenever there is a modification we should also perform the hazop. And hazop should not be end at one time. It should be periodically reviewed. Best practice is to do hazop in every 5 years, because always there is advancement of technology. There will be lots of upgradation in terms of instruments or equipments, and there can be issues then can be uncovered at later stage only, because as the plant goes out running there is some change in the production pattern or also change in the products that are produced. Also the capacity of the plant changes. So as all this thing changes slowly, then the hazards are also changes, or sometimes new hazards come up. So that's why it is very essential to conduct this hazard in every 5 years, 6 years, or whatever the time the management stipulates for it. This is the steps of the hazop study. If you are new to the hazop, then it will be difficult for you to understand these steps at this moment. But I will again follow these steps while I will be explaining with the practical examples. So that time you will be easily correlating with this. Anyway, if you see that first step of any job, the first step is obviously defining the scope. What is the scope of this hazard study, whether it is whole plant or some modification or periodic review, whatever it is, whatever the scope of the hazard, that should be defined first. Second, determine the study nodes and design intents of the node. Okay, so what is node and what is the design intent of a node? uh, that is maybe sounded little new to you. The node is nothing but it is a section of the process. So if you see that this is your whole process, you cannot do the hazard study on the whole process at once. So you will divide it in small section. So one section of the process is called node. So this is called a node. Now when the node is defined, we need to understand the design intent of the node. Why is this node? What is this design intent? What is the pressure that it is supposed to hold? What is the temperature that it's supposed to hold? So, or uh, why this particular loop? Whether this is to control the temperature or control the pressure, so that we need to know. So that is a design intent. Now apply guide words to each nodes. There are a couple of guide words that like no, less, more. These are guide words which are added to the parameters like no, no flow, no pressure, like that. We'll discuss later in detail. Determine the causes. So if some deviation is there, like more flow is there, what is the reason for that deviation? That is one. Now brainstorm the consequence. If that deviation occurs, what will happen? So that is the consequence. And identify the safeguards, whether we have any safeguards against them or not. After this, we need to identify the recommendation and document all the results. Now again, here these definitions are given. So node, as I have told you, this is a section of the process. Design intends that how the process is expected to behave. Cause or deviation is the way the process differ or vary. Consequence, result of the deviation. So it can be process hazard, it can be operability issue also. So this consequences we are talking about uh, in the preview of hazop study only. In other different hazard and identification techniques, the operability issue sometimes is not considered, but for the hazard it is considered. Now the consequence can be financial consequence, can be safety risk, consequence can be loss of reputation, consequence can be environmental consequences. Safeguard is what safeguard we have to reduce the cause frequency of the cause and or mitigate the after effect or mitigate the consequence. So there is two things are there, one is prevent and another is mitigate. So if you have a very high flow situation and if you have a ESD valve to close in case of the high flow, so that is a prevention, so that is a safeguard. And if the prevention fails, if somehow there is a loss of containment and in that time you have a gas detectors to alarm the operator, so that will reduce the consequence by mitigating it. So these are different type of the safeguards that are used in the process industry. Okay, now we will take a practical example and try to understand how the hazard can be conducted. We'll be going through each of these steps discussed. So first, if you can see, the feed flow is this is basically a HP separator. So HP separator, what it does, it separates the liquid and the vapor. So the feed that is coming here is contents of vapor plus liquid. Okay, so as this goes into the HP separator, from the bottom of the HP separator the liquid gets separated and from the top the vapor goes out. Okay, now the maintaining level of the HP separator is very important, because otherwise what will happen, that this separation will not occur and either in the vapor line liquid will go or in the liquid line the mixed flow will occur. So this will eventually cause problem in the process. Okay, now you can see there are two level switches. This is one and this is one. One level switches is connected to LV001, which is liquid level control valve. So this trying to control the system. So this is our basic process control system or BPCS. And this is another level switch which is connected to the ESD system. And what we will do in case of low level, this valve will be closed. Okay. Now the output of the HP separator goes to another drum or vessel from where the liquid drains from the bottom, and if some vapor comes, this vapor again goes out. Okay. So now we are into the first step of hazop study. So we should define the scope. So our scope is to do the hazop study of HP separator drain line. So what will be our node in this case? This will be our node. We'll be discussing about this section. Okay. So define scope is complete. Now obviously determine node and design intent. So what basically, as I have shown you, that this is our node, and this is the section we are interested about, and we are also, what we are doing, we are marking up the PNID. This is normally done. So normally the red mark is done on the PNID, and this PNID is called markup PNID. So HAJOP starts with the markup PNID. And what is the design intent of this particular node? Design intent of this node is to ensure the separation of the liquid and the vapor in the HP separator, and there should not be any high level or low level happening on the HP separator, resulting in the process upset. So our step 2 of determination of node is now complete. Now apply guide words. As we have learned in the steps of the HAJOP study, there are a couple of guide words that are added to the parameter to know the type of the deviation that can occur. So what are these guide words? This can be no, more, less, as well as, part of, reverse, other than. There are other useful guide words also, like where else, before, after, early, faster, etc. Okay. Now, like for example, like we have more. So if we have more, we will add it to the any parameter like flow. So more flow, or more pressure, more temperature, or less flow, less temperature, less flow, like that. So we will now see how the deviation can be formed. So when the guide word is added to the parameter, it creates the deviation. So like no flow, more pressure, as well as one phase and two phase. Other than operation, maintenance has also problem. So this type of deviations are created, and that deviation is added to the process to know what will happen when there is a situation like high pressure or no flow or more flow. So next step is obviously to create the consequence, cause consequence and safeguard table. So this is actually the format, the HAJOP report format. So you can see at first, you can prepare it in the Excel, or I can give also a template of the same. So first you need to have the site, maybe XYZ, then unit number you can write here, just I have written HP separator, node description, HP separator bottom drain line. Now the deviation. So deviation can be no flow, more flow, less flow, reverse flow. So all these are given. Now think of the situation when the no flow can occur. No flow can occur if that ESD valve fails. that ESD valve fails and XB closes, in that case no flow situation can occur, right? So what will happen in that case? Level will increase in V001. So is there any safeguard for that? Yes, there is a safeguard. Level high alarm is being provided. So this will be a safeguard. What is the other cause of no flow? It can be the control valve can be fail close, maybe due to the any problem. Another cause may be operator might mistake close the manual isolation valve, that is before or after the control valve. So in that case also level increase will happen. And in for all this consequence we have one safeguard, that is level high alarm. Okay. And what is our recommendation? We can have a small recommendation that we can provide the limit switch on the manual bypass provided, right? Then there can be another situation like more flow. Now more flow, when it can happen? When the control valve stuck open, that time more flow can happen. Or if the manual bypass valve around the control valve is opened by mistake, that case also more flow can happen. So what will happen in that case? In that case level will decrease, resulting in gas breakthrough, right? So what is the safeguard? One is alarm, and second is we have also low trip, right? We have low trip for XB100, so that will safeguard this thing. So now we have the cause, consequence, and safeguard matrix is ready, right? So this is the way is normally hazop is performed, and this recommendation comes up. So sometimes this recommendation are like it must be followed, or sometimes it can be like may be followed. So it is not very essential, but if it is followed, so it is always better. It will always increase your safety and availability of the system. So after all the recommendations are populated, then again then some screening is done, and uh, based on the team, the hazop team, the final recommendations are being formulated. So also this is the last step is documentation and record. And as I have said that this document is prepared for all the nodes, and one common file is being prepared, and that is signed and reviewed by the hazop chairman, and that should be also accepted by the site plant manager, and that is kept as record. Now what are the advantages of this hazop process? Because there are many uh, hazard identification process, but what is the advantage of this hazop? So first of all, hazop is a team event. So when you always know, when you work as a team, the experience of all the person gets added. So it is always very fruitful, and the team, as you can see, the comprised of like chemical engineer, chemist, operation supervisor, maintenance supervisor, instrument supervisor. So all of them are together, so they have expertise in some field, they have knowledge of the other, and combined they can identify the hazards in a better way. Then it is easy to verify. It is a complete documented study, and it can be completed at very early stages of the design, because it does not need so much of information. It does not need what is your, suppose your equipment type would be. It does not need the data sheet of the instrument. It does not need any quantitative data about the equipments or the process. So it can be completed at the very early stages of the design, and that is very helpful, because when you give any recommendation at the early stages of design, the chances of incorporation of that increases, because the cost is less at that time. Now, what are the disadvantages? Well, the team effort is a kind of disadvantage in the sense that it requires lots of time and resources, and but again, this is a, if you want to increase your safety and plant availability, this time and resource needs to be spent. It is not a waste, it is a investment. Another point is it only concerns the hazard that is inside the process. There can be impacts, other things, other weather related issues or other complication that may affect the system from outside. That thing is not considered normally in hazard study. So I hope you got an overall idea about how, what the hazard is, how the hazop is conducted, what are the different steps, and uh, maybe I have gone too fast, but you can again pause the video and try to do the hazop analysis of that particular node I have given, or you can take your process and you can define a particular node and try to do a hazop analysis, and then you can compare your analysis with actual hazop reports. This all things will help you to understand this, but just keep in mind that hazop is an qualitative hazard identification technique. Thank you so much.